Welcome all. Today in building services, we will get to know about the earthing in the electrical systems. First of all, what is earthing? Which is the process of connecting the metallic bodies of all the electrical apparatus and the equipments to the huge mass of a wire by using the wire which has the negligible resistance is called as the earthing. So the term earthing means connecting the neutral point of the supply system or the non-current carrying part of the electrical apparatus to the general mass of an earth in such a manner that all times an immediate discharge of electrical energy takes place without any danger. So next is about the concept of earthing system. So all living peoples are working in a residential, commercial and industrial buildings. So particularly the operators and the personals who are in close operation and contact with the electrical systems and machineries should be protected against the possible electrification. So in order to achieve this, the earthing system was installed to define and designed and installed according to the standard requirements in order to meet out the protection. Next is about the advantages of the earthing. So it provides an alternate path for the fault current to flow so that it will not endanger the users, and it also ensures that all the exposed conductive paths do not reach a dangerous potential, and it maintains the voltage at any part of the electrical systems at the known value so as to prevent over the current or the excessive voltage on an appliances or an equipment. What a good earthing means. So the good earthing must have the low impedance which is enough to cut off the current in a quick time, that is less than 0 0.4 second. Then fault current is much more than the full load current of the circuit which melts the fuse. So hence the appliances is disconnected automatically from the supply mains. Next is about the qualities of the good earthing. So it must be of low electrical resistance and good corrosion resistance and able to dissipate a high fault current repeatedly. Next is the purpose of earthing. In order to save human life from danger of the electrical shock or death by blowing a fuse, that is to provide an alternative path for the fault current to flow so that it will not damage or danger it will cause danger to the humans, and also to protect the buildings, machineries and appliances under the faulty conditions, so to ensure that all exposed conductive paths do not reach a dangerous potential, and to provide a safe path to dissipate lightning and short circuit currents. Then to maintain the voltage at any part of an electrical system at a known value so that to prevent over the current or excessive voltage on the appliances or the equipments, and also to provide protection against the static electricity from the friction. Next, we will know about the electrical shock. So, the electrical shock occurs when two portions of the person's body comes in contact with an electrical conductor of the circuit, which is at the different potentials. So, that will produce the potential difference across the body. So, the human body do have some resistance to resist the current flow, and when the body is connected between two conductors at different potential, a circuit is formed throughout the body so the current will flow through it. When the human body comes in contact with only one part of it, there is only one conductor, the circuit will not be able to form, so that there will be a no proper flow of the current. So when the human body comes in contact with the circuit conductor, no matter what the voltage is, there is potential for harm. The higher potential difference, the more the damage will be. The effect of an electrical shock is the function of what part of the body comes in contact with each conductor, and the resistance of each contact points, the surface resistance of the body at the contact as well as the other factor. So if it is able to form a circuit, then there will be a no problem. If it is not able to form the circuit, then there will be a damage for the life of the person. When the electrical contact is such that the current circuit path is through the body is across the hand, then there will be the greater potential for death. So this is an example, that is, the human body will be able to there is a transmit or a the amount of current which can be flow is through the human body is about 500 to 60,000 ohms, depending upon the moisture which is present in the skin of an individual. The human body do have some resistance. That is, the resistance varies from 500 ohms to 66 lakh ohms. So as the skin becomes moist, the contact resistance drops. So it is based upon the moisture content, moisture which is present in the skin. If it is more moist, then there will be a less resistance to the current. So if the skin is moist due to sweat that contains salt, the resistance drops. So if the skin is less with the moisture, then there will be having the higher resistance. So when the high voltage such as the 13,800 volt is involved in the body, it literally cooked, and it at times it makes us to explode. Next is about the short circuit. So to analyze how an electrical shock occurs and how grounding is applied, you need to look into a circuit which is involved in it. So this is an example of the short circuit that consists of the source, a transformer, or the generators. For all AC circuits, then circuit protection, conductors, and the load. Short circuit is nothing but any unintended connection across the circuit connectors between the power source and the load. So the short circuits are classified as voltage shorts, momentary shorts, intermittent shorts, or high impedance shorts. So the voltage short is a rare, is a very low resistance connection such as two connectors being bolted together. So most shorts are high resistance, or they are momentary or intermittent. So the high resistance short starts out as the high resistance or the impedance connection, but usually progress to a low impedance connection. So in electrical systems, shorts are classified as phase to phase, phase to neutral, or phase to ground short. Almost most of the shorts are phase to ground, and shorts which start as a phase to phase or phase to neutral progress to a phase to ground short. So when considering the short circuit and protecting against the damage, they can cause, one needs to know that what is the maximum amount of short circuit current that can flow in a given circuit. Next is the equipment earthing. So in case of insulation failure, the primary objective of connecting all the above points and apparatus to the earth is to release the charge accumulated on them immediately to the earth, so that the person coming in contact will not experience any electrical shock. Next is about the maximum value of the earth resistance to be achieved. That is equipment to be earth and maximum value of earth resistance to be achieved in terms of ohm. So equipments, large power stations, maximum value of earth resistance is 0.5 ohms. Then in major substations, 1 ohm. Small substation, 2 ohms. Factories substation, 1 ohm. Lattice steel towers, 3 ohms. Then industrial machine and the equipments, 0.5 ohms. So the earth resistance will be depending upon the moisture content in the soil. Thank you.